In this video, we're going to start to learn the basics of arrays in C. So arrays can store multiple values of the same data type. So it's important to understand that our arrays in C, they're only storing one single data type. And they always have a fixed size. So to start exploring arrays, I just have the C visualizer pulled up that's linked from the course website because it gives us a nice visualization. So our array declarations are a lot like our declarations for other data types, but this right here is saying declare a char array of length 3. So we put the data type first, we put the name of our variable, which in this case happens to be name, so that's the variable name, and then this is the length. So this char array is going to store 3 chars. And so what this declaration statement is doing is it's telling the compiler to reserve in memory 3 contiguous memory locations that can store chars. So if we just take a look at this, we can see what that might look like. So here we see that we have reserved space in memory for our variable name, which is a char array. So it has 3 slots. And at this point, so we haven't, the red arrow means that'll be the next line that we execute. So at this point, we haven't executed any of these lines yet, so we haven't put any data in there yet. But as I go through these lines of C code, we can see that each of these memory locations is assigned the value that we pass in here. And so we see name is char array, and here we have an example of an integer array. And so we would say that the integer array nums has size 5. And so here we just declared our name array, and here we both declared the nums array and we assigned it values with the int 1, int 2, 3, 4. So that's one way that we can initialize array is using the curly brackets, or we can just declare it and set each location as we go. So you'll find sometimes in your programs you'll declare an array that's longer than you might even fill in, because like I said before, we can't change the size of an array once we've created it. So if you want to just create a really big array so that you know that you won't need to create a new one, that's sometimes a good strategy while you're programming with arrays. So we already see here that we use the square bracket notation both to assign the size of the array, but also to access the positions, the values that are at the positions of the array. So we would say here that name sub 0, subscript 0, the first position, is being assigned to value the character B. And in C, the compiler will actually allow you to access array indices that don't actually make sense for your array. So let's just go back here. And so we see here that, for example, nums is an integer array of size 5. And so we should really only be accessing the subscripts 0, 1, 2, 3, and 4. But the C compiler is going to have no problem if I do something like set nums sub 5, so even though my size is 5, my subscripts are just 0, 1, 2, 3, 4, but it's going to let me set this to, say, 6. But nums has no element sub 5. There is no, should be nothing at nums sub 5. So let's just visualize this and see what happens. So just starting from the top of my program here, first we run through those assignment statements for our name array, and then we do our initialization of the integer array nums. We can see we've stored a 1, a 2, a 3, a 4, and a 5. And now, and we can also see they're really small, I don't know if you can see them, but our actual subscript values are 0, 1, 2, 3, 4. There's no nums at 5. But here I am saying nums at 5, assign 6 to that place in memory. And when I run this, the compiler, well, first off, it compiled. I got no complaint from the compiler. But when I actually go to run this, I may get a runtime error. I may just get, if I access this, I may get something that doesn't make sense. And so this is just an important common error that you should be aware of. It's called overflowing your array. And the C compiler will not catch it for you. Next, we'll see something that you'll do all the time with arrays, which is use for loops to access their elements or assign values at different subscripts. So I have a example C source code here where we're going to see how we can use a for loop to assign values in an array. So let's suppose that I would like to fill this array, squares, an int array, with the square of the subscript. So for example, I would like squares at 3 to be 9. So I could do this, right, with my initialization. So squares at 0 should be 0, squares at 1 should be 1, 1 squared is 1, squares at 2 should be 4, etc., right? But that's going to be a lot of typing. And usually our goal when we're programming is to minimize typing. So what I could do is use a for loop. So I could do something like for, and I'll just declare a local variable here. And let's say I go from 0, so that allows me to start at the first index of my array. I'm going to go until I is less than 100. So this is where I'm catching my overflow error. So if I had done something like less than or equal to 100, I would assign the 100th subscript, right? But my array only has subscripts 0 through 99 when my size is 100. And let's just go ahead and make ourselves a constant here. Size of 100. That's just a little nicer. So I don't have to be typing 100 there. Oops. Do I have caps lock on? I might. Okay. And then this would be size as well. Just a good habit to be in. If you ever are typing the same number over and over again, you probably should make it a constant. And then we'd like to increment I by 1. And then, oops. So as I'm going through this loop, I is the index, and so just square at I is going to be assigned the value I times I, right? because I'd like when this is 0, it's going to be 0. When it's 1, it's going to be 1. When it's 2, it's going to be 4, etc. And so, it's squares, not square. Luckily, Vim is doing some checking for me. And at this point, maybe I just run this to make sure that it works. I'll compile it to array example. I want to see all the errors, and the source code is here. And I guess I'm getting a warning that squares is not used. Let me just go look at that. I certainly am setting it, but maybe let's just check that our squares at 3 is indeed 9. So let's take a look. Squares at 3 equals, and I want to take a look at squares at 3, and that should be good. Let's try compiling again. I guess now I'm using it, and so the compiler's happy with me. And my check looks good. So that is an example of using a for loop with an array. The thing I'll just point out here is when I am using the subscript, so using my bracket notation, say I wanted, I guess, just like I've done right here, so I'm accessing the whatever is at squares sub 3. So I can put something in here that's not just a literal integer, but it has to resolve to an integer. So I could do something like 2 plus 1, and this is still going to work. Maybe we'll just see that. But as you probably would guess, if I put, say, a double in here, that's not going to work, right? Maybe that's obvious, but here we can see our array subscript is not an integer, and so that gives me an error. And so that is basics of arrays.